student, today we saw the similarity match to the theorem of the areas of similar triangles. The statement of that theorem is when two triangles are similar, then the ratio of the areas of those triangles is equal to the ratio of the squares of the corresponding sides. I repeat the theorem once again. When two triangles are similar, then the ratio of their areas of those triangles is equal to the ratio of the squares of their corresponding sides. Here two triangles are given, triangle ABC and triangle PQR, which are similar triangles. That means in given triangle ABC, similar triangle PQR is given, and let we take AD is perpendicular to BC and PS is perpendicular to QR, and AD is perpendicular to BC and PS is perpendicular to QR. That is given, and we have to prove that the areas of these two triangles, the ratio of the areas of these two triangles, area of triangle ABC upon area of triangle PQR, is equal to the ratio of the areas of these two triangles is equal to the ratio of the squares of corresponding sides. That means the corresponding sides AB and PQ. Therefore, AB square upon PQ square is equal to BC square upon QR square is equal to AC square upon PR square. We have to prove that. This. Now, for the proof, we learn the ratio of the areas of two triangles in the first lecture. That means from that these two triangles ABC and PQR is given. BC is the base and AD is the height. In triangle PQR, QR is the base and PS is the height. Therefore, area of triangle ABC upon area of triangle PQR is equal to the ratio of the product of their bases and corresponding heights. That means BC into AD upon QR into PS. This is equation number 1. This we learn in the first lecture, the ratios of the areas of two triangles in that theorem. Okay. Now, these two triangles are similar, which is given. Now, triangle ABC, similar triangle PQR, hence their sides are in proportions and their angles are corresponding angles are congruent. Therefore, angle B and angle Q, these are congruent. Therefore, angle B congruent angle Q. That is equation number 2. And similarly, AB upon PQ is equal to BC upon QR is equal to AC upon PR. This is equation number 3. Because of CSST, the corresponding sides of the similar triangle, and this is from by CAST. The corresponding angle of similar triangle. This is corresponding side of similar triangle. Now we take these two right angle triangle. Now in triangle ADB and triangle PSQ. बघा मी दोन ट्रायंगल घेतले, राइट एंगल ट्रायंगल ADB and PSQ. In these two triangles, ADB and PSQ, these are equal because of that are right angle. Angle ADB equal angle PSQ because of each 90, and we prove that angle B and angle Q is also equal. That means angle ABD is equal to angle PQS in equation number 2. That means we congruent two angles of these two triangles. That means these two triangles are similar. Therefore, triangle ADB similar triangle PSQ by AA test. These two triangles are similar by AA test. Now, these two triangles are similar, therefore their corresponding sides are congruent. Corresponding sides are proportional, therefore AD upon PS is equal to AB upon PQ. We take these two ratios only. AD upon PS is equal to AB upon PQ. This is equation number 4 by CSST. With corresponding sides of similar triangle. These two triangles are similar, therefore AD upon PS is equal to AB upon PQ. Now from 1 we get area of triangle ABC upon area of triangle PQR is equal to BC upon QR into AD upon PS. Okay, from first we get BC into AD upon QR into PS. We separated that BC upon QR into AD upon PS. In equation number 3, here BC upon QR is equal to AB upon PQ. These two ratios, first two ratios, here AB upon PQ is equal to BC upon QR. That means for BC upon QR, I write AB upon PQ. Okay, from equation number 3. Similarly, from equation number 4, AD upon PS is equal to also AB upon PQ. Hence, I write for AD upon PS, there is AB upon PQ. Okay, that means AB square upon PQ square. This is equal to AB square upon PQ square. Now, we get the proof. Hence, these are corresponding sides. AB upon PQ is equal to BC upon QR. Therefore, BC square upon QR square is also equal to AB square upon PQ square is equal to also AC square upon PR square, which is get the proof. Okay. There are some examples on this. We saw that examples now. Students, this theorem, in general we write this theorem like this. We write this theorem like this. If these two triangles are similar, triangle 1 and triangle 2 are the similar, then a1 upon a2 is equal to s1 square upon s2 square. Here a1 and a2 are the areas of the triangles and s1 and s2 are the corresponding sides. For our hot questions, one property is here. If these two triangles are similar, then a1 upon a2 is equal to s1 square upon s2 square is also equal to h1 square upon h2 square, where h1 and h2 are the heights, is also equal to m1 square upon m2 square, where m1 and m2 are the medians, and p1 square upon p2 square, where p1 and p2 are the perimeters. That means S1, S are the sides, H height, M median, and P is the perimeter. That means the sum of the all sides of a triangles. We write this property. You remember that property. Now we solve some examples on it. Students, we get examples on this theorem. In the practice set for 1.4, the first example, the ratio of the corresponding sides of a similar triangles is 3/5. Find the ratios of their areas. Now we solve this example. They doesn't given the name of the triangles. That means we take two triangles like this, triangle 1 similar triangle 2, and the ratio of the corresponding sides are given. That means s1 upon s2 is given, which is 3/5, and we have to find the ratio of their areas. That means a1 upon a2 we have to find. Now, by theorem of areas of similar triangle, a1 upon a2 is equal to s1 square upon s2 square. This is our formula. Hence, that is equal to s1 upon s2 bracket square. We take the square separate. s1 upon s2 is given 3 upon 5, hence is equal to 3 upon 5 bracket square. Therefore, a1 upon a2 is equal to, the square of 3 is 9 upon 25. Hence, this is our final answer. Answer is, the ratios a1 upon a1 as a2 is equal to 9 as 25. This is our final answer. Now, we saw another example. So students, in this example, triangle ABC similar triangle DEF is given. The ratio of the areas up to these two triangles is given 16 as 25. BC is given 2.2 centimeter and we have to find EF. That means they are given area of triangle ABC upon area of triangle DEF is equal to 16 upon 25. Now these are the similar triangle is given, triangle ABC, similar triangle DEF. So we take the equation number 1. These two triangles are similar triangles are given. Therefore, by the theorem of the areas of similar triangles, we get the ratio of the areas of these two triangles, area of triangle ABC upon area of triangle DEF is equal to the ratio of the squares of their corresponding sides. The corresponding sides are BC and EF. That means BC square upon EF square. These are BC and EF are the corresponding sides. The reason is the areas of similar triangle. Now substitute the values. Area of triangle ABC upon area of triangle DEF is equal to 16 upon 25 is equal to the value of BC is 2.2 bracket square upon EF square. 16 is the square of 4 and 25 is the square of 5. Therefore 60, that means square of 4 upon 25, that is the square of 5, is equal to 2.2 bracket square upon EF bracket square. Now these are all have the perfect square. Hence by taking the square root of both sides, we get 4. The square root of 4 square is equal to 4 upon 5 is equal to 2.2 upon EF. The reason is taking the square root of both sides. The reason is important. Now by cross multiplication we get 4 into EF is equal to 2.2 into 5. Therefore EF is equal to 2.2 into 5, which is 11.50 divided by 4. Hence EF is equal to, we divide this, we get 2.75 centimeter. Hence our final answer is EF is equal to 2.75 centimeter. That is our final answer.